We're going to look at an example of the definite integral and substitution, and I'm going to do this one question two ways. So you can choose to do this question. It's up to you which method you want to use. So whatever one makes sense to you, you should go with that one. Okay. So the first way, method one. Okay. The first way is to sort of ignore the definite part and just do the substitution. So we're going to let u equal 2x squared plus 1, and then du dx is 4x, and then du is 4x dx, and then 1/4 du is x dx. So now I'm ready for the substitution part, and I'm ignoring the fact that it's a definite integral for this part, and that is going to give me 1/4 u to the 4 du, which is just 1/4 u to the 4 du, which is equal to 1/4 u to the 5 over 5 plus c, which is u to the 5 over 20 plus c. And then once I've figured that out separately, not equal to my original question, because I can't let a definite integral equal an indefinite integral, then I can go up here and use that fact with the proper substitution back to get 2x squared plus 1 to the 5th over 20. And again, I can ignore the plus c because it's a definite integral from 0 to 1. And so I used the substitution to find me the antiderivative. And now I can use the fundamental theorem of calculus to solve the definite integral. So I'm going to put a 1 in there, and I would get 2 times 1 plus 1 is 3 to the 5th over 20. And then minus, I put a 0 in there, and I get 1 to the 5th, so I get 1/20th. And then, we can just, I don't have a calculator, so I'll just leave that as my answer. Okay, that's one way to do the question. So this is perfectly acceptable, but just keep things clear and don't set things equal to things they're not equal to. Okay, so this is a nice way to approach the question. All right, so we're going to do this example again with a slightly different method. All right, so same question, 0 to 1, x, 2x squared plus 1 to the 4 dx. Okay, so the other way to do the question, and I won't redo this work, I'll just leave it here, is to say that this equals this. So it's equivalent to 1/4 u to the 4 du, and then actually figure out what these are in terms of u. So these are x values. And here's how we turn them into u values. So I would say, I'm just going to write this all out because so you can see it. I would say 2 times 1 squared plus 1 and 2 times 0 squared plus 1. So if you actually change those to u values, you can just not substitute back and just evaluate this integral will be the same as this one if it's all in terms of u. All in terms of u. So now this would equal 1/4. and this is 3, and this is 1. Okay, and then I'm just going to go down here and say this is, so now I'm saying it's equal all the way along because a definite integral equals a number, and these are going to be equivalent. So let's just see that it really is. So that I can leave the 1/4 out front here, and then I get u to the 5 over 5, and then that's going to be from 1 to 3. I'm just going to suck the 1/4 back inside, so over 20, 1 to 3, and then I get 3 to the 5th over 20 minus 1 to the 5th over 20, and I end up with the same answer. Okay. So this might make more sense to you to just find the answer, sub it back in terms of x, and then just solve the question that way. And the tricky part with this is remembering to change these over to u values. And then you can just set the integrals equal to each other, and you don't actually have to sub back, and you can find the answer that way.